And we're back on my Huanan X79 motherboard computer build. I've had it for about 2 months now. The only really thing that's changed is I just got a new case for it, but it's been working perfectly. I've had little to no crashes when I'm encoding video, or I run it a lot. I use it it's on about 8 hours a day or so for the past 2 months. And for those of you from last video, you may not have known this, but I actually have 2 builds with the identical X79 motherboard, and both of them, so far, no problems at all. So let's get a closer look at them. So luckily, to access the VRMs, there's just 2 Phillips head screws here, and also down on the chipset, there's just 2 Phillips head screws. So let's get these off. These little heat sinks came off very easily. This is just the little heat sink for the chipset, and this is the heat sink for the VRM. You can see it does have a pretty decent amount of fins on it and some thermal tape. So first we're going to look at the chipset, and special thanks from last video's viewer, Andy Bjorn. I hope I pronounced that correctly. He said that on his Huanan X79 board, the chipset was scratched. And you can see it reads BD82 C602J. So these are scratched because Huanan is reusing C602 server chipsets from Intel. Now, the board has been working fine for me, but keep in mind you are getting a used chipset. I'm pretty sure I was wrong about the PCI-E lanes last video, but this is going to get a little bit complicated. So the processor, the Xeon E5-1650V2, has 40 PCI-Express 3.0 lanes, and these are all divided among this 4X slot, this 16X slot, this 1X slot, this other 16X slot, but this I think is a 4X slot. Now, I'm not 100% sure here, but this top PCI Express slot has 32 resistors and 32 direct lines to the processor. Now, I can only assume that that means it's 16 complete circuits from the slot to the processor, which would be 16 PCI Express lanes. Now, this bottom Express slot has the same thing, 16 total circuits directly wired to the CPU and back. However, this bottom slot, it's advertised as 16X, but it only seems to have 4 complete circuits directly wired to the CPU. Now, this is Gen 3 speed, so you may not run into a bottleneck, but I think they did this on purpose because they needed 4 more lanes for this NVMe right here, because this, I believe, is a 4X wired directly to the processor as well. But the C602 chipset has 8 of its own dedicated PCI Express Gen 2 lanes for 4 gigabytes per second of total bandwidth, and this is merely a controller to supply bandwidth through the 2 SATA 6 gigabit slots, the 4 SATA 3 gigabit slots, and then all of the USB 3.0, 2.0, and networking here and down here. The VRM is definitely a highlight of this board. The V-core, the voltage that gets directly supplied to the CPU, comes in through this 8-pin EPS connector and does go through, I believe, 7 true phases, with each having its respective integrated controller, 2 driver MOSFETs, choke, and capacitor. And you could just easily measure this by 1, 2, 3, 4, 5, 6, 7 chokes, or 7 pairs of MOSFETs. Voltage control for the memory really isn't impressive. It's pretty standard. You got the controller with the 2 MOSFETs and the choke. So this is a single phase for this bank, and then you get the same thing over here with another single phase for this bank. We're idling right now just on the desktop, and power draw is approximately, not sure if you can see that, 100 watts, 98 watts, 99, just around 100 watts. So not too good when you're idle. Single GPU heaven benchmark. We're drawing about 290 to 300 watts. This is just with the GPU maxed out. I'm gonna hit it with the CPU stress in a minute. Alright, my CPU is being stress tested at the same time as Unigine Heaven. Both my graphics card and my processor at a pretty heavy load. It's really not liking this. So the power consumption on this, strikingly, isn't much more. 320, 325, 330. It's about as much as I can get it to go to. Just got a second one of these RX 580s, so as promised, we're going to put it in there and see how it works. First time turning on the system with two cards. We're going to get video output. Hey, we got video output. We're in the BIOS. And after the BIOS, it went right into Windows first try. Great news, I'm running a 3D render test with both GPUs in GPU-Z, and they both are fully recognized PCI-Express 16x 3.0 speeds. Awesome. Idle again. Let's check out power draw with two graphics cards. Still around 104 to 105. Alright. And I attribute that to the second GPU typically not being on until you actually launch a 3D application. Having benchmark running now with two GPUs. Both are at full 100% load. Power draw is fluctuating around 500 watts. Full GPU and CPU load. Power consumption 550, 560, 570. Still within reach of my 650 watt power supply. Now it's time to compare single and multi GPU benchmarks.
Gonna stop. Oh, let's break it. Damn!
So would I recommend getting two RX 580s? No, not really, unless you're some kind of video editor or you know for certain that your games support Crossfire. Not too many games support Crossfire nowadays, but it was definitely a lot of fun getting this tested out, and I'm glad to see that Crossfire works perfectly on the Huanan X79 motherboard. So, thank you for watching.